Hello, my Algebra 2 students. It is day 2 of Unit 8, and we're starting on page 3 of the packet. So where we start today, it's asking us to graph the cubic functions and just circle the x-intercepts because that's what we're going to focus on. So get your graphing calculator out, into your y equals, clear out anything you might have, and you want to type in this first equation here. So x cubed minus 3x squared minus 6x plus 8. Now, I would say typically go to Zoom 6 to reset your window, and feel free to do that anyways. But we're going to change the window so that it matches what you have here. So here's your x minimum, your x maximum, and then your x max. And then down here would be our y min and then our y max. So under window, change it so it matches. So I'm going to go from -5 up to +5, and then -20 up to +20, and then hit graph. You're just going to get a better view of it and be able to kind of see what's happening here. So now when we sketch it, you should be able to see where your x-intercepts are. So my x-intercepts are clearly over here at -2. So I'm just going to move my calculator because I'm right-handed and it's in my way. So back here at -2, and then it looks like it's crossing here at +1, and then again at 2, 3, 4. All right, so when I sketch this, to the best of my ability, just kind of coming up, coming back down, and keeps going. All right, so here's 1, 2, 3 x-intercepts. So when it asks what's the number, 3 is what I'm looking for. What are the actual roots? Well, that's the same as the x-intercept. They're happening at -2, 0, happening at 1, 0, and at 4, 0. Right? If we needed to and we couldn't tell, don't forget, you could do second trace, oops, I'm a little off the screen there, 0, to be able to get those exact roots. Or in this case, because I think that they're pretty, I can go right to my table and I can kind of confirm it there. But just little things to note. Otherwise, let's do the next one. So get rid of what we have in there and let's type in our x cubed plus 9x squared plus 25x and then plus 17. All right, keep the same window, so just hit graph. Ooh. So if I look, it's crossing here at -1, and it has like this little wave that goes on, but that's about it. All right, so the number of x-intercepts, I just have 1, and it's at the value of -1, 0. And then the last part, try this last one. Clear this out. We have 2x cubed minus 12x squared plus 18x. All right, if I hit graph, all right, it looks like it's crossing right here at 0. And then at 1, 2, 3, it kind of touches and then bounces back up. So it's going to come down, touch, and go back up. So in that case, I really only have 2 x-intercepts, and they are at 0, 0 and at 3, 0. All right. What we want to look at is the fact that when it is a cubic function, that there should be 3 x-intercepts or roots. You can kind of use that term interchangeably. And in each of these, we actually do have 3. You just can't always tell. So something to keep in mind, this first one, I would say we had 3 real roots. We can actually see them, all 3 spots where it intersects. Here, if you're only seeing 1 real root, it actually means that the other 2 are imaginary. And think, when we graphed parabolas and they had imaginary roots, they didn't hit the x-axis. So that's kind of what's going on here, is that you're not seeing it hit the x-axis. As for the last one, there are technically 3 roots here, but because you only see 2 distinct real roots, where it touches the x-axis and then bounces back up, That's called a double root. So just like with a parabola, when it had a double root, it would be tangent to the x-axis and it would only really hit once. Same thing here. All right, so I'm going to say when the graph is tangent to the x-axis, this is a double root. So really you do have 3 real roots. It's just one is doubled. All right, so here's the third one. All right, so those are kind of the scenarios that can happen. But notice it has to hit at least one time. All right, so come on down here and let's take a little algebraic look at this. It says consider the cubic whose equation is given as this. All right, determine the x-intercepts using the zero factor property. All that means is if I want an x-intercept, I'm setting y equal to 0, or in this case, f of x equal to 0. And then once we do that, our goal will be to factor and then solve. So on the left-hand side of the equation, we can put in 0. So negative x cubed plus x squared plus 12x. Right? Remember, you're always looking for a GCF first if possible. We have one here. You can take out a single x. I'm going to take out negative x to make this an x squared. That's going to make things a little easier. That'll flip the sign and make this negative x. That'll flip the sign here and make it negative 12. Now it's just a little add multiply. So we can keep going. So this is going to be x minus 4 times x plus 3. And then when we go to solve, technically you're setting negative x equal to 0, which just gives you x equals 0. This would be x minus 4 equals 0, so we get 4. Same game over here, we get x equals negative 3. All right, because the y value is 0, that means this is the point 0, 0, 4, 0, negative 3, 0. These are the roots or the x-intercepts. Which can actually even be called the zeros of the function as well. So over here, go ahead and plot them. So you have this little graph. We got 0, 0. We've got negative 1, 2, 3, 0. And we have 1, 2, 3, 4, 0. What I'd want you to now think of is if we sketch this without our calculator, you have to think about what kind of cubic function it is. Well, there's a negative x cubed. So now we go back to the notes from day 1. We know 2 things about an x cubed, that the tails go opposite directions. And you kind of think about it in terms of like a positive slanted line or a negative slanted line. If it's positive, then it would slant up to the right, down to the left. In this case, because of the negative, then what the tails are going to do is go up to the left, down to the right. Right? And so I can sketch this without using my calculator, just based on saying, go to the point furthest to the left, tail should go up to the left. Go to the intercept furthest to the right, tail should go down to the right. And then we can kind of fill in. So it's going to go past, it has to come back through and hit at 0, 0, come up, and then back down. And so in factored form, we can show that this equation would look like negative x and then comma x plus 3 and x minus 4, which FYI, that's going to be helpful in a moment. If we wanted to, could we grab our calculator and confirm our graph? Sure, right? So just different things to think about, but look at how much we were able to do without our calculator. Now this year, I will never take your calculator from you, but pre-calc, you will see quizzes and tests that require you to not have a calculator. All right, let's keep moving. So on to the next page. Example 5 says, consider the quartic function g of x equaling x to the 4th minus 5x squared plus 4. So algebraically determine the x-intercepts. Again, we're going to set y or g of x equal to 0. Let's do it. So 0 goes on the left, x to the 4th minus 5x squared plus 4. This is actually an add multiply, where it's just going to be an x squared at the start of each parenthesis. So when you think about it, I go -4 minus 1, that'll add up to -5, multiply to +4. We can now keep factoring. This is the difference of squares. So x plus 2, x minus 2. So is this guy, x plus 1, x minus 1. So we end up with 4 roots here. We were going to get a root at -2, +2, -1, +1. And what shouldn't be surprising is that there are 4 roots or x-intercepts because it's an x to the 4th problem. Right? So come over here at -2, you can plot your point, -1, +1, +2. So we have 1, 2, 3, 4 roots. All right, now I want you to think about the tails for an x to the 4th. So it's an even function. The tails go the same direction. So either both up or both down. The fact that this is a positive x to the 4th means that it'll both go up, sort of like a parabola that opens up, right? But now we start to see a different shape other than the parabola because it has to pass through the x-axis. So it's going to go down and then come back up and then go back down and come back up. And now, is it perfectly symmetrical like that? I don't know. I'd have to grab my calculator to confirm it. Right? So because we didn't look at the last one on the calculator, let's maybe quick check this guy. So if I do x and raise it to the 4th, and then -5x squared and +4 and hit graph, it's actually really symmetrical. So we can see just how perfect our little sketch is just based on knowing what the x-intercepts are and then the pattern with the tails. All right, let's try this next one. This one, we got a big old equation here. It says sketch the graph on the axes, label the x-intercepts. All right, we are going to use the calculator this time. So if we grab the calculator, let's go right back. Let's get rid of this. We got an x, raise it to the 4th power, plus 3x cubed, just kidding, minus 35x squared, minus 39x, and plus 70. All right. So in this case, take a look at the window that's being set for us. Let's go right now and change it. So -10 to +10. And then look at your y min, -500. And then your y maximum, +500. You can change the scaling if you want. It doesn't really matter. Like I could change it to 100 just so it doesn't show me all these tick marks. All right, there we go. So for this, we can actually pretty nicely see the intercepts. So let me slide over so you can see all this at once. All right. If I look at my tick marks, it looks like it's crossing here at -2. And then if I keep counting, 3, 4, 5, 6, 7, so -7. And then over here at +1. And then again at 2, 3, 4, 5. And if you can't see it perfectly on mine, look closely at yours. You should be able to count those tick marks. It actually comes out pretty beautifully. All right, let's sketch. So it's going to go down, come back up, come back down. And here's an example where it's not perfectly symmetrical. Right? And that's fine. All right, it says based on your graph, express this quartic in factored form. All right, well, if we know what the x-intercepts are, which we certainly do, let's list them out. We've got -7, -2, 1, and 5. Think about what we did on the last page. We were able to take those and work them backwards. So what I mean by that is in parentheses, we can now move this over so it becomes x plus 7. Think about moving that over. It'd become x plus 2. This would be x minus 1. This would be x minus 5. So you're just seeing the opposite sign there. And then all of those would be multiplied together and set equal to y. And now, can we check it on the calculator? Yep. So I'm going to go right back into y2 and make it x plus 7. Close that up. X minus 2, or excuse me, plus 2. And then x minus 1. Close it up. And then x minus 5. And now I'm just going to hit graph. And now if we look carefully, you can see it tracing in red directly over where it was. If you couldn't see it, I promise you, it did happen. All right. So we check that right in the calculator. And it shows that by using those x-intercepts, we could come up with the equation itself. Now we're going to see in the future that sometimes it takes a little more work than that, but the most basic one, it'll work. All right, we have one last page to look at, and we're not going to look at all the questions on this page. We're going to save some for class. So what I'd like to do is the part A of each question. So number 7 says sketch the graph of each, and then it's just based on being in factored form already. So it's actually nice and easy. So what I want you to think of here is I need to know what the x-intercepts are. So you would just think about setting it equal to 0. I need to know what's the degree of the polynomial. So like 3 or 4, meaning like, is it an x cubed or an x to the 4th? Because this way I can think about what the tails are going to look like. All right. So is that leading term positive or negative? All right. For this very first one, if we look at setting it equal to 0, the x-intercepts, and keep in mind, you don't really have to show me that step. We could probably look at this and just see it. You're going to flip all the values. So it's going to cross at x equaling 4, 1, that would be -1. This one will switch to be -2. Right? So that means if I were to multiply all these x times x times x times x, this is an x to the 4th power. So it's a degree of 4. The last thing, you have a negative in front. The a value being negative means for an x to the 4th, both the tails are going to go together and they're going to be down. All right, draw a little sketch here. So give yourself a set of x and y axes. We're going to cross at -1, -2, and then 1 and 4. So plot those 4 points. The tails go from the furthest intercepts to the left and right. So from the furthest to the left, draw down, furthest to the right, draw down, and then it just has to pass through. So it's going to come back and hit at -1, hit at +1. Right? How far up or down you choose to stretch it, no big deal, because it's only a sketch. It's not meant to be perfect. All right, let's save B for a little recap for tomorrow. And then our last question of the day, let's slide it up. Write a cubic or quartic function in intercept, meaning factored form, whose x-intercepts are nice integers, so pretty whole numbers, and then assume that the a value is 1 or -1. Awesome. All right, so for this very first one, take note of your x-intercepts. There's 3 x-intercepts. That tells you something right there. So at -2, at 0, and at 3. So in factored form, make sure we would switch the sign. So x plus 2, x minus 0, and then x minus 3. And then look at the tails. For the tails, it's going up to the right, down to the left. That means my a value has to be positive. And as when I said there's 3 x-intercepts, that means this guy's an x cubed. So it makes sense that the tails are going opposite. So it would be positive in front. Could you clean this up a little? Sure. We could make it just x and then x plus 2 and x minus 3. And that would be perfectly fine as well. All right, let's save this last guy over here. For a recap, we'll start there tomorrow. Thanks, guys.